This is part 3, what is a limit? Question 3a, look at the graph and determine the limit if it exists. So again, we start with, it's asking us for the limit as x approaches 1. So we're going to look at x approaching 1 from the left and x approaching 1 from the right. And again, we're going to see what's our curve approaching. From the left, it's approaching this hole here. And from the right, it's also approaching this hole here. And so it's approaching the same value, even though there's a hole there, it's approaching 2. So in our graphical analysis, it's approaching 2, even though there is no point there at 2. But we're going to explain why the limit still exists and is 2 from an algebraic perspective, even though there's a hole there. And we'll kind of use some of the things we learned in grade 11 as well. So I'm going to move this up. All right, so B says use algebra to determine the limit. So we're talking about the same limit again. And explain how to, in quotation marks, get out of the trap. So what trap do we have right now algebraically? If we were to let x approach 1, our denominator would approach 1 minus 1, which is 0. And that's not okay. We learned about that last week. So when it says get out of the trap, get out of when we allow x to approach 1, the denominator to approach 0. So there should be some method that we can use. In this case, that method that we can use is factoring. So if I factor x squared minus 1, it's a difference of squares, and it will give me x minus 1 times x plus 1. And the denominator can just leave the same. I'll add these brackets here to emphasize. So now that we factored the numerator, we can actually divide out the x minus 1s. And we're left with the limit as x approaches 1 of x plus 1. And now it's safe to let x approach 1. So as x approaches 1, this limit approaches 1 plus 1, which is 2, which agrees with our graphical analysis. So part C says explain why the graph of the function y equals x squared minus 1 over x minus 1 looks the way it does. So if I bring this back down for a second, why does it look like a straight line with a hole in the middle? Or a hole at 1, sorry, not in the middle, but a hole when x is 1. Okay, so we're going to go back up here and explain that in a graphical sense. Okay, so we've got this function y equals x squared minus 1 over x minus 1. So this brings us back to rational functions from grade 11. And we want to draw a graph of it. Well, first we know that x can't ever equal 1, because then our denominator would be 0, and we can't have a denominator of 0. Can't divide by 0. Again, we can use the same strategy we used in question B, which is to factor the numerator, our difference of squares. And then we can divide out the x minus 1 because they're like factors. And we're left with simplifying this rational function into just y equals x plus 1, but we keep in mind that x can never actually equal 1. So we've changed what this function looks like to an equivalent function. That's easier to draw. Okay, so in this case, y equals x plus 1 we could see would be a line with a slope of 1 and a y-intercept of 1, provided x is never equal to 1. So if we go up to the graph again, we can see that what we've drawn here is a line that has a y-intercept of 1, a slope of 1, up 1 over 1, up 1 over 1, up 1 over 1. But at 1, we're not allowed to have a value, so instead there's a hole there. And that is going to be the end of part 3.